Good day everyone, and welcome back to the X Explorer for another video, an exciting video this time for 3 reasons. Number 1 is that I finished building the Charles Kitchen regen receiver and it works great. I really like it. Let's say that I'm 99% happy with the way it performs. So we're going to take a closer look at the latest changes that I made on the schematic and how it looks at this point. The number 2 is that I also finished building the audio amplifier entirely made with transistors to replace the LM386 audio amplifier. And I really like the way this one sounds. I think I like it a lot more than the one with the LM386. And the third part is going to be about a giveaway announcement, just because recently I reached the 5,000 subscribers limit. And of course, that wouldn't be possible without you all. So I'm going to have a giveaway thanks to my friends from PCBWay. I'm going to have a bunch of PCB boards. I'm going to pick 3 winners. We're going to take a closer look at this in a little bit. I'm going to pick 3 winners. All 3 will receive the same package. If one of you, I'm going to pick the winners from all the subscribers to the channel. In case one of the winners will not contact me to give me the address where I'm going to have to send the PCB boards package, then I'm going to pick another winner in a later video. I'm going to make the announcement about the winners in the video that will be separate from this series, but it's going to be somehow related because it's going to be a step-by-step instruction video on how to build this Charles Kitchen regen receiver using the new PCB board that I'm going to design in just a little bit. And by that time, I'm going to receive the PCB board, build it, and show it to you in a video, so you don't have any headaches and problems while you're building yours, to make sure that it's going to work first time. So that will be the video when I'm going to announce the winners for these 3 prizes. So let's get at the desk, have a closer look at what you will receive, and then we're going to talk about the receiver. But of course, not before saying thank you to my friends at PCBWay for sponsoring this video and for the prizes offered to you. If you want to build beautiful homebrew projects, choose PCBWay. With excellent PCB prototyping services, all you have to do is to open your account on PCBWay, use the software of your choice to design your PCB board, upload the Gerber files, and place your order. Soon you will receive your professional and great quality PCB boards for your projects. PCBWay also offers PCB assembly services, SMD stencils, CNC, 3D printing, and even more. PCBWay is the way. Now, before we continue with the receiver, I'm going to show you really quick the prizes for the giveaway. So the first one is the really nice ruler from PCBWay. After that, we have the 700 milliwatts minimalist CW transmitter. Then we have the Squeaky, the RF sniffer. Then we have this QRP RF watt meter, 2 separate scales RF watt meter. Then the PTTCO2 CW transceiver. We have the Sputnik regen receiver, and we'll also have one board for the audio amplifier, which I'm going to talk about a little bit later in this video, and of course the new Charles Kitchen regen receiver design. Now don't forget that on the blog, all these projects that I have here, they have articles, and also there are videos on the channel about all these projects, so if you decide to build one of them, you have some materials to start with. One more time, thank you to my friends at PCBWay for these nice prizes. Don't forget, I'm going to pick 3 winners from all the subscribers to the channel, and I'm going to announce them later on in the video when we're going to do the step-by-step instructions on how to build this new Charles Kitchen regen receiver design using the PCB board that I will have for that one. So, talking about the receiver, let's get back to it and see the latest changes. So let's go really quick through the schematic of the receiver. Basically, I tried to keep it as original as possible as it was in the original Charles Kitchen design, and only made changes when I was really forced to. So here we're going to have 12 volts on the input. Basically, from 12 volts I'm going to power the audio amplifier. Then this one goes through a bit of filtering through the voltage regulator, and on the output here I have 8.2 volts. With this 8.2 volts, I'm going to power the RF buffer or preamplifier, depends how you want to call it, and it will also power the varactor circuit. And then this one goes through this 6.8 Zener diode, and it will power the transistor. Here on the regen side, the changes that I made is that I'm using 470 picofarads at this point and 1 kilo ohms potentiometer to ground, and this is my regen control. Here on the antenna side, on the RF buffer, the potentiometer also doesn't connect straight to ground. It will go through this 100 ohms resistor. On the output here, just to finish really quick with what is simple, I placed this 10 nanofarads capacitor before the output capacitor just to get rid of the really annoying high-end frequencies which are bothering me a lot. In an older original Charles Kitchen design, here it was just 1 nanofarad, so if you want you can use that one. Then we have this varactor circuit, because everything else is pretty much the same as the original circuit. I'm using 2 multi-turn potentiometers over here, one for the main tuning, the second one for the fine tuning. Here where I have the main tuning, it doesn't go to ground, it goes through this resistor. Probably I'm going to end up placing here a variable resistor, like a trimmer resistor, and we get to pick the value between 1 or like 0 to 10 kilo ohms, and this will help us together with the coil to tune the receiver between 6.8 megahertz up to 14.4 megahertz. And of course I have the inductor, which the RF coil, which has 4 separate windings. The one for the frequency counter has 4 turns. The one for the regen control has 8 turns. This one for the antenna side has 3 turns at this point, but this number might depend on the antenna that you're using. I'm using an end-fed half-wave antenna for the 80 meters band, and 3 turns for me is more than enough, because I don't want the receiver to overload with signal, and it's enough for me that during the propagation times, when the propagation is pretty bad and the signals are weak, I can increase the signal coming from the antenna with this potentiometer, and basically I will be able to also receive some weak stations. Now of course, if they are extremely weak that you cannot even pick them up with a proper industrial receiver, definitely you might not be able to pick them up with this one, but sometimes you might. So you might be surprised how much this can do. And over here we have this receiver winding. This one has 20 turns right now. I might be able to increase this to 21 turns. We'll see later on in the final video. And over here I replaced the capacitor that goes from the varactor circuit to the gate of the transistor. In the past I was using 10 nanofarads. Right now I went down to 680 picofarads. I have the best results out of this, trying to cover this frequency range. So anyway, that's it about the schematic. I'm going to post it anyway in the blog article once I finish building the whole thing, and I'm going to make the step-by-step instructional video. But for now, at least you have an idea about the latest changes that I made, and we get to listen really quick to talking about performance of how it sounded last night, somewhere around 3 a.m. when I was still testing the receiver with some really nice DX stations, and then we're going to go really quick on the audio amplifier part.
Kilo Golf 8 Yankee Alpha, see you, CO. Yeah, excellent. Boy, your 300 and the X beam sounded great. 7300 on you sounds like you figure it. Oh, it sounds wonderful. No problem. Signal 5 and 8, 58, very strong power. See you, CO. Take care, man. God bless you, KG8Y8. Thank you so much, and thank you so much, and have a great summer, Lord. Anyone else? Kilo Golf 8 Yankee Alpha 20. Something ending in sugar, hello, right? know there's another station in there, maybe with sugar in the ending of the call, but I'm sorry, I cannot quite make you out. Anyone else? Kilo, Germany, 8, Yankee, Alpha, Hello, 20, DX. Hi. Okay, yeah. VU2, Mike, Zulu Tango, from Victor Echo 3, Echo Papa Sierra. Yes, thank you for the, I think you said 5.9. Good to hear you. This feeding into your direction with about 500 watts and a 2-element cubicle quad. Before you go, please tell me what you're running. What is your antenna and power, over?
So this is the finished receiver. Basically we have the receiver over here and the audio amplifier in this side. It will be able to power some sort of small speaker, not very loud, I'm going to warn you from now, but we're going to listen to it and you'll see how loud it is. But it's excellent for headphones, it sounds fantastic. It will power the speaker as well, but the LM386 as it is, it will not be able to power this speaker. It will be very low in volume. So anyway, this one performs a lot better. Now I decided not to build a CW filter for this receiver. I don't think it's worth it. But if you want, you can play around with some switching some capacitors in and out just to get rid of the very high frequencies, and this will help you a little bit in receiving better CW signals. But basically the receiver doesn't have the selectivity that I wish it would have, but this is the same problem for all regen receivers, and honestly I don't see the point on making a CW filter trying to complicate such a simple receiver. So I'm trying to keep it as a really simple project that will be also be able to be built by beginners. I don't want to complicate it by adding a bunch of stages. But anyway, if you're building it Manhattan style like me, you're free to add a CW filter somewhere in between the receiver and the audio amplifier. I tried that yesterday. I was experimenting with it and I built a filter. Oh my god, it's so narrow, you have no idea. But so narrow that the speaker was actually ringing, and I didn't like that. So anyway, let's talk really quick about the audio amplifier now. So the amplifier schematic is very simple, and it's based on the schematic made by Rick Anderson, Kilo Echo 3, India Juliet, unfortunately silent key. The original schematic had another preamplifier before this one, identical to this one, but for me I thought it's a little bit too much and it was too powerful and I didn't need that, so I reduced everything to 4 transistors. I only made minor changes just because I wanted to get it to sound a little bit better in sense of to sound the way I like it. Maybe Rick liked it the way he presented it in the schematic. So what I did now, before going through the modifications, actually here, for example, this is a standalone audio amplifier, but if I want to have it in the receiver, as I will have it now, I did not install C1 and C2 because these two are filtering capacitors and I already have filtering on the input of the receiver, so these two are not necessarily. Here on the output, for example, I would connect a switch as well, and I get to pick if the signal goes to a jack output for the headphones or it goes to the speaker, and this way I can connect the headphones, have them connected all the time, and I can just pick from the switch where I want the signal to go to, maybe to the speaker or to the headphones. If I have someone in the room and I bother them, I'm just going listening into the speaker, I'm just going to move on headphones and that's it. Or you can install one of those jack outputs with the switch incorporated. I don't like those, so that's the reason why I want to install a separate switch for that. Here I reduced the value. I think in the original schematic from Rick, this resistor was 1 kilo ohms, but the idea is that this resistor the value of this resistor we have to pick depending on the transistors that you're using over here. And the way you pick the value of this transistor, let's say I'm powering the whole amplifier with 12 volts, the measurement here where these two transistors connect between each other and also to the positive of the capacitor, you will have to measure a voltage that is very, very close to the half of the voltage that you're powering with. So for example, I'm powering this one with 12 volts. My power over here measured should be somewhere around 6 volts, maybe 6.5, maybe 5.5, 5.8, but somewhere around 6.5 volts should be perfect. If this doesn't happen, and if in here, for example, I would use 1 kilo ohm potentiometer, this 2N3906 will basically run overheated all the time. So I have to lower this resistance until this one goes down in temperature as well and is more stable and it doesn't overheat. So right now I'm measuring 6.5 volts with 330 ohms, but I also used other transistors. I built this amplifier a couple of times, and depending on the transistors, I may have to go even down to 220 ohms. So yeah, it might depend on the transistors that you're using. What else? I'm going to show you, by the way, now that I have this thermal camera, I'm going to show you how much they heat up. Right now I think it stays somewhere around 45-50 Celsius degrees, but with the 1 kilo ohms resistor it was going nearly up to 85 Celsius degrees, which is a little bit too much. Now I read a couple of more articles to similar amplifiers like these ones, and sometimes if you have problems with these two transistors overheating, over here you can place a 10 ohms resistor, and over here you can place another 10 ohms resistor, and that would help them stabilize in temperature, and that should fix the problem. But so far I never had that issue, so I never installed them. What else was? The resistor over here, right now I'm using 470 kilo ohms. If you think that the gain of the amplifier, the preamplifier, is a little bit too much for this part of the amplifier, you might want to increase the value of this one, maybe up to 1 mega ohm or 2.2 mega ohms, and that should somehow lower the output of this preamplifier just enough that it will not overdrive this amplifier part. By the way, it works great as a guitar practice amplifier. I tried that too, and it sounds fantastic. And if you play a little bit harder, it has a natural distortion and it sounds really nice, so you might want to play around with that. Yeah, I've been testing this one with a lot of things. So yeah, I think that's it. Oh, over here Rick had a 100 nanofarads capacitor. It will cut a lot of the high frequencies, but I think it was cutting too much, so I lowered it to 20 nanofarads. For me was pretty okay. I still have some low-end frequencies available, and I also cut a little bit of the high frequencies. So I'm pretty happy with the way this schematic ended up so far, and it sounds great for me. Of course, you can make adjustments depending on your own preferences. By the way, this point over here, this is not, these two diodes, they connect between each other and to the bases of the transistors. They are not connected to this wire over here going to the from the transistors and the capacitor to the resistors, just in case, so it will not create confusion. So here we have the audio amplifier, very simple, just 4 transistors, and it can be very, very loud. Let's listen to the radio right now. So this is the Heathkit crystal radio CR1 that I built some while ago through this audio amplifier.
și reciclare și există cazul nefericit în care uită niște ciocană, îi scoate bobina, eventual dacă e monitor plat, îmi scoate și placa.
So yeah, it can be very, very loud. I'm really happy about the way it works.
Și se întâmplă acest lucru destul de mult. În România lipsește un sistem de coordonare.
All right, enough with this one. Let's get to the receiver and hopefully we get to listen if we're lucky for some good propagation. I don't know about that because it's pretty cloudy outside. Yeah, the propagation is pretty low right now. Probably I'm going to put the end of the video, some video that I was recording last night or the night before, and yeah, we'll see. But this is how it sounds for the AM broadcast bands. Pretty loud as well, and I'm lucky. My Turkish friends don't put music, so I don't have copyright issues. But if I go on the 20 meters band, I have some weak signals over here. So yeah, as I was saying, it's not very loud when it comes to CW and SSB. But this is only when the propagation is not very good. When the propagation is strong, the SSB signals especially can get quite loud, and those CW signals as well. Let's see if we can find some SSB signals. Ah, there you go. So this is SSB through the speaker straight away. And of course with the RF gain you can increase the signal a little bit, but if you go all the way up then you have a lot of AM broadcast band interferences. Anyway, let me show you what I recorded a couple of nights ago, and you will get the sound. You will get the sound straight from the receiver, from the output of the audio amplifier through the Tascam audio recorder, and you will see how we would sound in your headphones, basically.
Ульяна 66, здравствуйте, ну потом повторите. Наши чувства включилось. Ульяна 66, знаки вопросы, РДС, УКЦ. По-моему... Papia forma principal, this is Alpha Oscar 75 Charlie Victor. Secure, Alpha Oscar 75 Charlie Victor.
助力医疗服务数字化，正在不断解决群众看病就医的难点、痛点、堵点，大大提高了人民群众获得感和幸福感。
各位听友，今年呢是中国接入国际互联网30周年，以下请听记者唐静采制的特别报道《30年往事》。
So I really hope you liked the way it turned out so far. Maybe I have some time to do some more tweaking by the time I finish doing the video with the step-by-step instructions. and I get it to work 100% the way I want it to, but we'll see about that. Anyway, I'm not sure exactly when I'm going to post that video. It might be either next week, at the end of the next week, or the week after, because it depends a lot of how much time I have to design the PCB board, and I also need a little bit of time to receive the PCB board from PCBWay, and then of course to move everything on the PCB board and film the whole video, instructional video. But that's when I'm going to announce the winners for the raffle of today. For now, I can just say thank you so much for the 5,000 subscribers. It means a lot to me, because that means that I'm not wasting my time over here making all these videos for you. So I very much appreciate this. So that's it for today. I'll see you in the next video. Until then, thank you for watching, and 73. Oh, wait, don't go. Did I show you the new mascots that my sister made for DX Explorer for the channel? Thank you so much. I really like it. It's I don't know, it doesn't have a name yet, so probably I might have to find a name for this guy, but it's really cute. So he's the new mascot for DX Explorer 73.